All right. So the basis of 6-7 was taking all the ideas that we've learned so far in chapter 6 and applying them now to equations. So evaluating these expressions with square roots, kind of rewriting them between different forms, moving some things over, just applying our algebra steps now to these square root equations. Let's recall our steps to how to solve these. So very similar to getting any variable by itself, we need to move some things over, whether using addition, subtraction, multiplication, and division. But our first goal is to isolate that square root. All right. So in order to get the variable by itself, which we're solving for, we first need to get the square root by itself. From there, I'm going to either square both sides, or if it was a cube root, I would cube both sides. We'll see an example at the end where maybe I have something raised to like the 2/3 power, raising it to the reciprocal, right? We talked about that a lot last Friday and on Monday as well in our review of section 6-7. So the first question you should always ask yourself is my radical isolated? If so, I can square both sides, which we're going to see a lot of today. Now, the first couple examples we're going to do are pretty easy. All right. So just squaring and then simplifying. You might see multiple steps within your root. You might need to move some things over before you square both sides. You might need to factor to simplify. So there's a variety of questions that I would expect to kind of see tomorrow on the quiz and familiarize yourself with. Okay. With that being said, what we're going to do is go through all the odds, and then very similar to what we've done all week, the evens will be due for homework. Sound good? So long as everyone participates and focuses, we'll have plenty of time to start that towards the end of class. All right. Number one. All right. My radical is isolated. There's no other term that I need to add or subtract to both sides, multiply and divide. So I'm going to start by undoing the square root. And to undo a square root, I have to do what on both sides? Square. Good. Remember that anytime you square root, it's going to eliminate it, and you're going to be left with whatever is inside your square root. So for this example, I have p inside of my square root, so that's what's going to be left over. And then 5 squared is what? 25. Good. You see there at the top, it says, remember to check for extraneous solutions. So in order to check, and what I would suggest doing tomorrow on the quiz is plugging your answer back into the original equation. You should get the same thing on both sides. So if I plug in 25, square root of 25 is 5. I have 5 equals 5 on both sides, so I'm good. All right. Always make sure that if you have time to do that, you go ahead and check your answer. And I'm not going to look for it in terms of points on the quiz, but I would suggest doing it. Okay. Number 3, very similar. I have the square root isolated, square both sides, I get 9 is equal to a, right? Plug it back in, square root of 9 is 3. I have 3 equals 3, so I know that's my right answer. Now, I wouldn't expect the question to be this similar, but like I said, we're kind of building up our steps here with how we solve these questions, okay? Any questions about the first page? Okay. Number 5, pretty similar, although now I have maybe an extra step involved inside my root. Like I said, you might have to multiply, divide, add, or subtract to get the root by itself, but then also do that after you square both sides. So in number 5, first question is my square root isolated? Well, if there's something inside the root, that's okay. If there's anything multiply, divide, add, or subtract on the outside, that's when I have an issue. So is my square root by itself? Okay, so then what should I do on both sides? Square. And what's going to be the answer on the left? So what's 6 squared? 36. What's left over on the right-hand side? 18p. And now instead of just having my variable by itself, I have a one-step equation here. To get p by itself, I have to do what on both sides? Divide by 18. And I get p is equal to 2. All right. Again, if you plug that in, 18 times p is 36. Square root of 36 is 6. So you get 6 equals 6 on both sides. Any questions there? Similar example with number 7. Notice that I don't just have my variable by itself underneath my square root, but the first question again, is my square root isolated? Yeah, right. So what can I do on both sides to start? Square it. 8 squared gives me what? 64. On the right-hand side, what's left over? N minus 3. And then just like number 5, right, I have that easy one-step equation where I'm either multiplying and dividing. In this case, I can add or subtract. So I'm going to add 3 to both sides to get n by itself. And I get 67 is equal to n. Okay. Any questions about that example or anything that we've done so far? So like I said, we're kind of doing a building block with this where each problem might, add an extra layer on top of what we saw before. And these questions are relatively easy. There's not a whole lot that we have to worry about. Our radical's already isolated. There's not a whole lot of moving over or anything like that. But that's not always going to be the case. Everybody good up until this point? Okay. Number 9, I'm going to walk through a little bit more on my own. The reason I'm going to do that is because we're taking a leap now from some easier type problems to a little bit more challenging problems. And there was an example that we saw last Thursday when we introduced section 6.7, where maybe we needed to use a different method to find our solutions. Maybe we don't use our algebra steps where we add or subtract things over and we have those 1 or 2 step equations. Notice that at number 9, I have a variable on either side of my equal sign, okay? I still want to get rid of my square root. That should be my objective. First to isolate it and then get rid of it. Well, to get rid of the square root on this side, I'm going to square both sides. But whatever I do to one side, I'm going to do to the other, right? And I'm going to square that entire quantity n minus 3. So not just one of my terms, but the whole thing. Okay. So I have n minus 3 times n minus 3 on the left-hand side, n minus 1 left over on the right-hand side. All right. And all I did was just expand that from the n minus 3 squared to multiplying it together by itself. Well, a lot of times when we see a binomial, so that 2-term expression multiplied by a binomial, what process do we need to go through, in order to simplify the left-hand side? Foiling. Good. Exactly. So foiling, remember that stands for first, outer, inner, last. So if I multiply the first terms together, n times n gives me n squared. N times negative 3 gives me negative 3n. And I have that twice, right, from the inner terms as well. Negative 3 times negative 3 gives me a positive 9. So be careful with your integer rules as well. Everybody good so far? Well, I have an n squared in my problem. We're going to see a lot of examples like this as we progress through. So we're aware of, when we need to factor and things like that. Well, in order to start this process, I first want to combine like terms over here and then get all of my terms to the left-hand side. All right. Essentially, what we're doing is finding solutions where this would be equal to 0. So on the left-hand side, this will be n squared minus 6n plus 9 equals n minus 1 after combining like terms. And then I'm going to subtract the n and add the 1. I'm going to do that step 2 steps at once. So I'll get n squared minus 7n plus 10 is equal to 0. Yeah, I just did 2 steps at once. So instead of doing it, one at a time, subtracting the end of both sides. So I combine like terms here. and then add the 1 to both sides. So I have 9 plus 1 gives me 10. And the reason I'm doing that is to get 0 over here and all the terms on one side, so then I can start my factoring process. So a lot of times, like I said, anytime we see an n squared, x squared, whatever it may be, it's a good sign that we're probably going to have to factor in order to solve. And in each time that we do this today, we're just going to factor normally. So we want to ask ourselves, what are some factors of 10 that are going to multiply to give me positive 10 and add to give me negative 7? Negative 5 and negative 2. Good. So we need to recall some of our factoring methods as well in order to help us simplify some of these problems that we're going to encounter today. All right, and I'll give you a second to jot that down. From this step, we're pretty much done the entire problem, right? In order to solve this, and we talked about this, way back when we started doing factoring, I just set each of my factors there, each term or binomial equal to 0. So I'll have n minus 2 equals 0 and n minus 5 equals 0. So to find my solutions, I have a one-step equation. I'll just add 2 and add 5 to both sides. So I know n is equal to 2 and n is equal to 5 for my final solution. So now, comparative to some of the other questions we've seen, I have 2 solutions. The issue, though, is that I want to make sure I check my solutions as well. So if I do, if I plug in 2, what's 2 minus 3? Okay, so I have negative 1 on this side. 2 minus 1 is what? What's the square root of 1? 1. So I have negative 1 equals 1. Is that ever the case? No, right? They're 2 different numbers. So n equals 2 is not one of my solutions. If I plug in 5, 5 minus 3 is 2. 5 minus 1 is 4. Square root of 4 is 2. So I have 2 equals 2. So 5 is really my only solution. All right, this is why we want to make sure that we check our answers. Now, to be completely transparent, on the quiz tomorrow, the answers that you get will be the answers, but I want you to check just to make sure, right? Going through this process is important for us, not only in this class, but moving forward as well. All right. Any questions about number 9? Okay. Number 11. A little different. What's the first thing I need to do in number 11? Or what do we think the first thing is that we need to do? Add 1, right? So to isolate that root, I'm going to add 1 to both sides. So I have 3 equals the square root of 3p. Now what can I do on both sides? Square it. So I have 9 is equal to 3p. And I just have my one-step equation. I'll divide by 3 on both sides and get p is equal to 3. If you were to check that, square root of 3 times 3 is the square root of 9, which is 3, minus 1 is 2. So you have 2 equals 2, which works. All right. Any questions there? Okay. 13. What do I have to do in 13? How would I start this problem? Square both sides. Good, right? I have my radical that's isolated. Well, on the left-hand side, I'll get m squared. What do I have on the right-hand side? What's that become? Right, negative 32 plus 13m, just whatever's inside my radical. Well, notice that I have an m squared again. So what I'm going to probably think to do is factor here. And I'm going to move all my terms to one side. in order to start that process. So I'm going to have m squared minus 13m plus 42 equals 0. Okay. Everybody with me so far? Any questions? So I'm going to factor normally, and I need to ask myself, well, what are some factors of 42 that are going to multiply to give me that positive 42 and add to give me negative 13? Negative 7, negative 6. Good. Right? If you need to, make sure that you list out the factors. Okay? Just so you're, on the right page and on the right track with what is going to work for you. So m minus 7, m minus 6. So then what would my two solutions be? 7 and 6, right? As you progress through these problems, you can show this step where you set each equal to 0. For the most part, you should recognize that it's just going to change the sign of whatever that number is, right? So m equals 7 and m equals 6 are my two solutions. Now let's make sure that we check, all right? If I have 7, I plug that into my original equation, all right? What's 13 times 7? Use calculator if you need to. 91. Then what's negative 42 plus 91? 49. What's the square root of 49? 7. And then you have 7 equals 7. So 7 is one of my solutions. Now, if you plug in 6, what's 13 times 6? Well, if 13 times 7 was 91, 13 times 6 is going to be what? 78. Right? So then 78, negative 42 plus 78 is what? Love mental math. 36 is the square root of 36. So then 6 equals 6, right? So then you're good. So make sure that you're going through and actually checking your answers for each of those. All right. Any questions about 13? A lot of mental math this morning. Oh. Okay. Let's move on to 15. Should be in a little bit more of a groove by now with these types of questions. So what should I do on both sides to start? Square it. Right. Isolate my root and then square both sides. What's going to be left over on the right-hand side? So if I'm just looking at the squaring the square root. Yeah. 13 minus x. Now, one thing, just for the sake of time and, giving you a little bit of a shortcut here. I talked about this in class a few times, but I want us to really, understand this point, emphasize it so you don't have to worry about foiling and things like that. The easiest way to do something like this where you're squaring a binomial, square the first term. So what's x times x? X squared. Multiply the two terms together and then multiply that by 2. So what's negative 7 times x? And then what's negative 7x times 2? Negative 14x. And then square the second term. What's negative 7 times negative 7? 49. This is an easier way for you, instead of expanding it, worrying about first, outer, inner, last with the FOILing method. You can just square the first term, multiply them together, multiply that by 2, and then square the second term. And that gives you all 3 of your terms that you need. Okay. I'm going to have to go through the factoring process, so I need to get everything on one side. And I'll have x squared minus 13x plus 36 is equal to 0. Well, what two factors of 36 are going to multiply to give me positive 6, add to give me negative 13? two numbers are going to multiply to give me negative 30 or positive 36 and add to give me negative 13. Good. Nice job. Negative 9 and negative 4. So then what are my two solutions? Good. X equals 9, x equals 4. Let's just check though, just to make sure. So if I plug in 9, 9 minus 7 is 2. 13 minus 9 is 4. Square root of 4 is 2, so I get 2 equals 2. So I know 9 is a solution. If I plug in 4 though, 4 minus 7 is negative 3. 13 minus 4 is 9. Square root of 9 is positive 3. So 4 is not a solution, but 9 is a solution. Make sure that you go through and check your answers, especially when you are factoring to solve. Okay. Everybody good with that example? Okay. We're going to do 17 and 19, and then I'm just going to change 21, but we'll get to that in a second. All right. 17. What do I have to do on both sides to start? Square. Good. What's left over on the left-hand side? So after I square, negative 1 minus 2x is equal to x squared. Now what do I have to do on both sides? Or what should I do from this step? Right. Good. So I want to add the 1 and the 2x. Some of us might have thought to maybe subtract the x squared just because it's less steps. However, we want to make sure that that leading coefficient, if we're going to factor, is positive, right? Otherwise, we have to deal with taking out a negative and then distributing. It becomes a whole thing. So my equation now is going to be x squared plus 2x plus 1 equals 0. Well, factoring this is going to be really easy because what's the only factor of 1? 1, right? So I have x plus 1, x plus 1. I'll give you a second there to jot that down. I know I'm kind of moving a little bit quickly. And then what would my solution be? Negative 1. Okay. Let's check that just to be sure. If I plug in negative 1, well, negative 2 times negative 1 is 2. Negative 1 plus 2 is 1, and the square root of 1 is 1. But if this is a solution, that means 1 is equal to negative 1, which is not the case. In which case, we say we have no solution. All right. Again, to be transparent, there will not be an answer that's no solution tomorrow. All right. But in us understanding this skill, we want to make sure that we go through and check our answers. Number one, make sure to always do that. But then also, kind of understanding different solution types that we might have for these types of problems. Okay. Any questions about number 17? Okay. Number 19 is a little bit different, right? Kind of moving away from the factoring. What do I have to do to start? Square both sides, right? It seems a little mundane, but we are doing the same thing frequently. Remember that we want to get that by itself and then square. So I'll be left with n over 2 is equal to 1, right? From 1 times 1. Very similar example to what we saw earlier in class. Now I just have a one-step equation. Well, what do I need to do on both sides to get that variable by itself? Multiply by 2. Because these 2's will cancel. And then n is equal to 2. Okay. Any questions there? All right, the last question I want to do, I actually want to change what 21 says. So make sure that you write this down, because there's going to be a question very similar on the quiz tomorrow. So section 6.7 was a lot of square root equations where I'm either squaring both sides, cubing both sides, whatever it may be. And that was kind of what we talked about on day one. But on day two, on Friday, and what we discussed actually at the beginning of class on Monday of this week, was a problem when maybe I have a fractional exponent as well. All right. And I would expect to see one of each of these types of problems on the quiz. Well, does anybody remember? And I hope that we do, because we need to know this for tomorrow. What I need to do to start this problem. So so we are going to do the reciprocal, but I'm raising it to a power. It's not, don't think of it as multiplying, because multiplying is different than if I'm taking the exponent of something. So, but you're right. So first off, what is the reciprocal of 2/3? 3/2. So I'm going to raise each side to the power of 3/2. And the reason for that is, remember, a power raised to a power, I multiply them. So these are going to cancel, and I'm left with x minus 1. So that's pretty much going to happen every single time. That's the reason that we're doing it, is because we're getting rid of that fractional exponent on one side to be able to evaluate it on the other. Well, one thing that I said for us to do, and we talked about this on Friday and beginning of this week as well, is to rewrite this in radical form, because it's easier to simplify and understand kind of what's going on here if you put it in radical form. So I know I'm going to have a 4. What's my power for this? 3, right? That number in the numerator. And then what's my index? 2, which means I'm taking the square root. Now, I'm not going to write the 2 in there, but we need to be aware of what kind of root we're taking. All right. Is everybody with me so far? So just like the other questions, isolate that term raised to the fractional exponent, raise both sides to the reciprocal, and then rewrite the one side in radical form. Okay. Well, we need to simplify this right-hand side, right? The left-hand side I can't do anything with, so it's going to be x minus 1. But on the right-hand side, one thing that I said in class is that it's easier for us to start with the root of whatever that number is and then raise it to the exponent rather than the opposite. So the order in which we do this does not matter. The reason I'm saying that is because a lot of times you deal with smaller numbers. So for example, what's the square root of 4? 2. I'll do that first, then I'll raise 2 to the third power. What's 2 times 2 times 2? 8. Now, if you did the opposite, so 4 cubed, that gives you 64. Square root of 64 is 8. A lot of times, though, we might not be dealing with small numbers like this. Like, what if I said, for example, like 8 cubed and the square root of that, or 9 cubed and the square root of that? Okay, might be easier to do the root first. From here, though, I have a one-step equation. My answer is 9. All right. And then if you plug that back into the original, you should get 4 equals 4 on both sides. Okay. Any questions about that last example or anything that we covered today in class? Everybody good with this section, this concept? Okay. So what I want to do now, I'm just going to stop sharing my screen here. I'm actually going to stop recording as well.